We are now already at a place where human auditing is insufficient. The reason for that is not because human auditors are bad or not good enough at their job or whatever. The reason is because
Welcome, everyone, to another episode of the Ship Safely podcast. I'm your host, Sebastian, and today we're joined by the one and only Din Little, the founder of Blueshift and one of the most prolific builders and educators in the Solana ecosystem. Super excited today. Dean has spent over 20 years building systems across some of the most demanding domains in tech, from embedded control systems for aerospace to distributed network intelligence platforms like BitPing, to even like low-level Bitcoin infrastructure and tokenization protocols. So Dean, you've been everywhere. Um, he's currently the chief scientist at Zeus Network, where he has led the development of a Bitcoin client for Solana and implemented some really cool cryptographic primitives like SecP256K1 Schnorr signatures and some ZK friendly proof systems, which is really cool. As a technical advisor and core contributor to Jupiter, he also built something called Doves, which is the Oracle solution securing over $800 million worth in their perpetuals market. Now, as the Blueshift founder, he's focused on Solana core dev, open source tooling, and scaling access to top tier Solana development through free courses and gamified on chain learning. Dean, it's an honor to have you here.
pleasure to be here. What an intro.
Yeah, I mean, like, like your CV is probably like 10 pages long. It's
Yeah,
it's
lucky I
quite a
don't
lot
I
of
don't have to
stuff that
write those these days.
100%.
Yeah.
Yeah. So to kick things off, I want to ask you the same question I ask all our guests. What do you hope people will take away from this episode, and why should they stick around and listen?
I hope people will adopt my philosophy that you shouldn't have to ask for permission to make things better.
That's a good one. So let's jump into the first question. Um, you've got a really deep engineering background across many domains like aerospace, security, crypto, both cryptography and blockchain, right? What's pulled you into Solana? Why are you in this ecosystem? What was the spark behind, starting Blueshift?
Yeah, so originally I started working full time in blockchain back in like 2017. I started building stuff on Bitcoin. I also built some things on like EOS, a couple of other EVM chains and whatever. So I would not say I'm super, super OG, but relatively early in terms of like that was about the first time in history where you could be like a full-time blockchain developer as a career. And that's when I started out. Um, I had been interested in this space for a long time just due to like my sort of passion for like just using cryptography to protect people's money, like their finances, their communications from anyone who would try to control or coerce them. So that's what led me to Bitcoin. After building on Bitcoin for many, many years and many other blockchains as well, I got really, really good at Rust. I mean, when I say really good, I mean maybe not by the standard of like some of the people on this chain, but I think I'm a pretty good Rust dev, and I really like the language. And in 2022, a friend of mine was like, "Hey, like, come and use your Rust skills and teach people Solana." And I'm like, "Well, I've only ever like." really, kind of screwed around with Solana up until that point. I hadn't done like a whole bunch of stuff, but I got into it and I learned it probably in about like a month. And I realized like, oh, there's like no open source like program examples, or the ones that are there are all terrible. The tooling is not very good. The libraries are not very good. And so as someone who worked on Bitcoin, which is like, because of its like, what's the term? Uh, because of how primitive Bitcoin is, it's a very simple system in terms of the protocol, but it's very complicated in terms of everything you build on it due to the UTXO model. And coming to Solana just felt like, oh, this is so easy. There's like low hanging fruit everywhere. So I just kind of really felt like I could make a big difference. And I've always like historically been a big blocker. I believe that like blockchains should scale. Bitcoin should have scaled beyond 1 megabyte. And I think Solana is really great in the sense that the account model allows you to do shared state in the same way as Ethereum did, which enabled all these crazy DeFi applications. But the segregation of all of the state into different accounts allows you to have the unbounded parallelization that the UTXO model in Bitcoin enabled. And so it's really kind of like the best of all worlds for me.
Definitely. Yeah. If there's one thing Solana is doing amazingly is scaling. And of course that's also thanks to you. For those unfamiliar with Blueshift, can you, in your own words, explain what problems it's tackling and solving in this ecosystem?
Yeah, so there's a few things I would say that Blueshift does. So, firstly, we have a very big focus on self-guided education. Our philosophy is that the bootcamp model is good for some people, but not really scalable for the level of demand that we've seen for Solana developers. I'm sure you have tried to hire people and found it absolutely impossible, right? And even though it's
Yeah.
great, like for example, you guys as security guys, you got wrecked off or whoever, like doing good work. Um, but like quite frankly, like we need, probably hundreds of thousands more people. And so we kind of realized that boot camps are great, but it's very high effort. And if you can make like really, really high quality self-guided learning, the sort of people who are really motivated and will stick around are just going to like rip through that and build skills really quickly. And then beyond that, you'll also teach their AI agents or whatever, like so they can learn way faster, progress way faster than if they didn't have those resources. So we kind of are scaling Solana from the developer pipeline perspective, right? Another thing we do is we run a dev shop. We take on some of like the high profile clients who are moving to Solana from other chains, or maybe they're coming in from the Web2 ecosystem and they just need to partner with a good dev shop who will help them put their best foot forward, have the best possible start. A lot of them come to us. So, for example, like we helped Virtuals with their Solana expansion from base, and many such customers like that. Um, we also do core development. We have authored, I don't know how many, I'm going to say roughly 10 SIMDs, and I think about like 5 or 6 of them have been merged, and many of them are already in production. We are the first non-ANSA company to uh, create a SIMD, get it merged, implement it, and activate its feature gate on mainnet. So we are like bona
Amazing.
fide core contributors. And beyond that, we have a huge passion for tooling. We have released the Quasar framework. It was like 27 times smaller binaries than Anchor, about 5 or 6 times less CU usage. Um, we've also released SBPF, so like the most advanced comprehensive assembly tooling. Um, you also focus a lot on cryptography. We've released more cryptographic schemes than like any other, in fact, all other companies in this space combined. So we really just like go really hard on open source tooling and core dev, and then take the things we learned and teach them to people.
Oh, that's a super cool model. And going, double clicking on the education perspective, you've helped train a big chunk of, today's Solana developers going through Turbine and now Blueshift. Even though I really believe in this self-learning, um, I think that's the way to go forward. I think like these traditional education systems are going to slowly fade away
Yeah.
and they're going to, lose a bit of the market share in front of self-learning in the next years. But what do you still see as the hardest thing for new devs to grasp about on-chain Solana development?
I think a lot of our APIs are extremely unintuitive, and that's just basically down to the people who built the chain in the beginning just not knowing Rust. Like, I mean, if you've ever like looked at the syscalls, like you've got like Solana invoke C and Solana invoke Rust. So you've got like two different like calling conventions based upon the language, even though Rust and C have like basically interoperability between them. Um, there's like a lot of just really silly choices. Like Rust people like use like the ref slice thing that's used in C. It's like Rust community used that as like a pejorative term to like make fun of us, you know? Like there's a lot of like just really like bad API choices, right? So if you're trying to go like straight into like the low level, like if you're trying to do like Pinocchio or something, which is closer to Rust, right? You're not like shown a million macros or whatever. It's like parts of that are intuitive, but some of our APIs are not. And then like if you're given like something like Anchor, it just abstracts everything away, doesn't really feel super rusty. It's kind of like not immediately obvious, like why do I have like these accounts here and then like the instruction data here? Like, because when you think of like invoking a function in Rust, you don't think of having like two different types of like operands. You just like, I just put all of I just put it all into my function and call the function, right? So like a lot of weird stuff like that, the memory management, things like that as well. It's just odd patterns that, if you're like a regular Rust dev, you probably won't see. If you're an embedded systems Rust dev, you're probably right at home because you're used to those weird, quirky APIs. But that's probably not most people. So I think that's probably the hardest part.
Yeah, no, that makes total sense. As you were describing this, I realized as I was getting into Solana, those were exactly the same parts that I found the hardest as well. Um, Going, forward with Blueshift, what do you think the next phase looks like? Are you, focused on particular partnerships or a new curriculum or something like certification of talent in a more formal way?
So, like, my opinion is basically like we went and built our education platform. It was extremely successful. We've had like hundreds of students go through it. I think like over 1,000 NFTs minted. So when you like pass one of our courses, you can mint an NFT qualification to prove that you made it through. Um, and it's been used by like pretty much every super team around the world. It's been localized into a whole bunch of different languages. It was just used in China to run the Solar boot camp. So like, there's like very, very widespread use and reach of that content because it's open source and it's free. It's MIT licensed, so you can kind of use it however you want, right? But what we kind of realized was like we would have to go and make like two versions of everything, right? So we would go and make like the Anchor version, and then we'd have to go and make the Pinocchio version, and that was like really, really cumbersome. And so that's why like we recently built Quasar as like a framework, and that helps us to solve this problem. You don't have to choose between like reasonable developer experience and like really good performance. In fact, like the performance in some cases is actually even better than Pinocchio, not because Pinocchio is not performant, but because there's some optimizations that are only possible in the context of a library. Sorry, in a framework that is not possible in a library. So what we're doing right now is like stabilizing that, and then we're probably going to just make like maybe 3, 4 times as much content, but using that. But of course, we have to get it audited. We have to stabilize the API. We have to make sure that our community is happy with it. But that's sort of what we want to do. And that stops us from having to duplicate our effort every time we teach people how to make a new class of program. And then obviously at the same time, like if you try to build anything with AI, there's like probably at least a coin flip chance that it's going to reference one of our repos or one of our courses when it's trying to like reason through how to do that. So obviously, we also have to think in terms of how do we make our content widely available for AI to help people both just trying to vibe code something safely and trying to pursue their own self-guided learning. So from the education side, that's the way that we see that going.
I think like you touched on something really sensitive there, which is vibe coding something safely, right? I think like that's the key word there, right? Because I think like the problem with vibe coding is people tend to lose grasp of what they're building because it's just so easy, to keep prompting
Yeah.
and keep seeing the functionality pile on, but not pay attention to the fact that you're losing comprehension of what is in the code, right? But yeah, that's a perfect segue to the next part of the episode, which is about security and future proofing. So you've contributed to so many different systems like signature schemes, Oracle design, vault systems, right? What's your personal philosophy on designing for security in these kind of on-chain systems, which are very sensitive from a financial perspective?
Yeah. So I think I have a few philosophies on this, and like they've evolved over time. But I would say like my original philosophy, something that I've believed for over a decade and has never changed, is do not design your system in a way that you're trying to make sure that it will like never, ever, ever fail, but design your system in a way that it will fail gracefully. So, in other words, if the system breaks down, if anything goes wrong, it should break down in a way that doesn't lose people a bunch of money or fail catastrophically. You want it to fail gracefully. And the reason for that is because there are so many edge cases that humans cannot catch. There's also many edge cases that AI cannot catch. And the Venn diagram of that is not a perfect overlap either. There are plenty of attacks that AI will totally miss and humans will find, and vice versa. So I think design systems that fail gracefully, not catastrophically, is like the number one design philosophy that you could possibly hold, because systems will fail, right? Even if you've done a perfect job, you know. Um, like you think about like, like you make the perfect Turing machine and someone comes and snips your Turing tape. Now what? Like that's just the reality, right? Things will fail at some points. These systems are not infallible. Code is not law, right? Like what those electrons do is, hopefully going to follow your code, but not necessarily, right? Like we're dealing with
Yep.
fundamental forces of nature and force majeure and all sorts of things, right? So the second
Yeah.
thing that I would say is that we are now already at a place where human auditing is insufficient. Um, the reason for that is not because human auditors are bad or not good enough at their job or whatever. The reason is because the cost to discover a vulnerability is now so many orders of magnitude lower than the cost to find a vulnerability that it's very easy for everything to just like be attacked now. Like AI can find vulnerabilities in bytecode. AI just rooted every Linux distribution since like 2017 this morning, right? Like there's a
Copy
lot.
fail. Yeah.
Yeah, copy fail. So like, do you really think like just like think about how insanely like picky Linus Torvalds is with like commits and code and kernel contributions and stuff like you know do you really think your org is on average going to be like more picky than Linux? Like probably not, right? And Linux, like the number one most used software that's running all of our servers right now, it's probably like facilitating this call right now, like
100%.
if their thing is going to fall subject to these kind of attacks, like you will as well, right? So what I would suggest is moving forward, humans are going to have to move towards formal verification of everything. um, you still need human auditors because there is some kind of second and third order effect attacks that AI is not good at thinking about. So like AI is very good at like mechanical errors, right? Or logic
Yeah.
errors. But AI is not, in my experience, super good at evaluating second and third order effects and things that come about as a result of user behavior that is not intuitive to it from like a first principles reasoning sort of perspective. So I'd say like those are the two things that I hope that people take away from it.
Oh yeah, those are really good takeaways for this episode. Like if anyone is, is still watching at this point, like though that was, like pure gold. I think, that principle of graceful failing is super important because I think there's this huge misconception in the blockchain ecosystem, like not just Solana, but everywhere, that if you get an audit, you are 100% secure, right? And there's no such thing, right? And I
No.
think there's this huge misconception that you know either you know because they're not aware, people are not aware there's no such thing as 100% security, or they're misled. That there's this belief, right? So some people are really shocked when an audited platform gets hacked, and they're like, oh well, I thought this would never happen, right? And the same with, I think you mentioned formal verification. I remember there was this huge shock in 2021, I think it was, when SushiSwap got hacked, right? And it was a formally verified protocol. And also with formal verification, there's this pitfall of you might not formally verify all the possible properties that an attacker could exploit, right? You can't just maybe you
Right.
can't think about it, right, at the time. So yeah, there's always, I think, a risk regardless of what you're doing. And I totally agree that, given what AI can find today, human auditing is not sufficient.
Yeah.
So like, you need to combine those two things.
Yep.
That's what we're doing. So
Yep.
like, because bad guys are going to be using AI to find bugs. So yeah, but I think we could go on and on about this thing. But like, let's get to the next question, which is super exciting. You've designed something called Winternitz Vault. I hope I'm pronouncing it correctly.
Yep.
And this is amazing at securing cold assets. But PDAs are becoming a hot surface for DeFi, and would like to ask, where is the next innovation needed to be able to secure this active PDA signing?
Yeah, so actually, like the Winternet's Vault was just a proof of concept to show that it was computationally possible to implement Winternet signatures on Solana. We did that in January of 2025 in response to a guy on Twitter saying Solana will be the first victim of quantum. He was a Bitcoin maxi, and a month later he was looking into Solana. So maybe we did some damage there. But so we just last week, actually no, this week, sorry, released Winter Wallet, which is like a productionized version of this. It implements some additional security features that hardens it against any kind of attacks and whatever. It is already usable today for things like transferring tokens, upgrading programs, transferring LAMP ports, etc. So in terms of simple DeFi stuff that like say large asset providers would be interested in, like just for example, issuing or transferring assets, it's already like sufficient. Um, However, the big downside is that we are using truncated message. So ideally, a Winternet signature should be using 256 bits of security throughout, which provides about 128 bits of quantum security. Um, we are at around about, I think, 88 bits of quantum security, which is still honestly very good versus like theoretical quantum computers. Like if you had to choose between the thing that is vulnerable to Shor's algorithm or this, you 100% would choose this. Um, but the main downside is the compute costs are about 600K CUs, so it's still possible in a single transaction. But the signature size is about 700, I think it's 768 bytes. So at the end of the day, you don't have a whole lot of space left over after verifying that signature. Um, what we have actually just done this week and it will probably be released by the time this podcast is out, is we have proven the ability to verify Falcon 512 signatures for 200 KCUs in the VM without a syscall. So that's going to bring the signature size down to 666 bytes. It's also going to bring the compute cost down to about 200K, so just slightly above the VM default. So that should allow you to do some slightly more complicated interactions. We also just saw the release pipeline for Solana, was it Agave 4.1 that's due to come out in June. In Agave 4.1, we should be getting 4 kilobyte transactions. In that case, we will have surplus transaction space. So you would be able to use this to do like a Jupyter swap, or any kind of regular DeFi primitive would already be able to be secured by a Falcon signature or a Winternet signature. So now Solana has not just one, but two very robust post-quantum solutions without any protocol changes. And with the very minor protocol change of 4 kilobyte transactions, you can do everything you can do today with that.
That's amazing progress. Yeah, this episode is gonna be released in a few weeks, so by that time,
Yeah.
I think everyone's gonna be getting their hands dirty. Um, so trying this out. So is this already like available for people to try out if they wanna, play around with it?
We have so Winter Wallet is already live, open source, deployed on mainnet and DevNet. Um, the Solana Falcon 512 crate is actually on crates.io now. We haven't open sourced the implementation. So we still found about 20% optimizations we can do. We also don't want to release it without doing extensive fuzzing and soak testing. So we've done about 100 million iterations with zero divergence from two other Falcon libraries, but obviously, like, just like, for example, just because I can verify a legitimate signature doesn't mean I don't accidentally let through an illegitimate one, right? So there's a lot of things you have to do. Like, we have to make sure, for example, our number theoretic transform algorithm matches that of the other libraries, and all sorts of things like that that you have to do when it comes to like securing cryptography and then promoting it for general use, right? And that's before even getting to audit, right? So
Yeah, yeah.
um, the simple answer is yes, you can go use this now on mainnet. It will work. We're still doing a lot of work to make sure that it's like really good and robust, and is gonna do a good job of protecting funds.
That's awesome. Um, to continue this, quantum risk narrative, what do you think is a current, risk, still existing risk on Solana from the quantum perspective that
Hmm.
you'd love to see someone or more people or someone in particular build a solution for?
Um, So, like, one thing I'll say is that we're still using like AltBN 128 for all of our like ZK stuff. That's why I pushed really hard for us to get BLS 12381 into 4.0. The bits of security of AltBN 128, I think, is around like 100-ish bits, which is like extremely low when you consider that, like, like, okay, quantum computers might not come here tomorrow, but like it's still like a very, very low level of security for things that are supposed to be securing our privacy and whatever. And obviously, once quantum computers come out like that are sufficient to break like ECDSA or whatever, like they're toast. But they have the lowest bits of security, and that's pretty scary. So bumping to BLS 12381 buys us a little bit more budget in terms of like just how many qubits they would need to crack that. And I'd love to see people building stuff on BLS 12381, just so that we have higher bits of security versus our existing curve we're using. Another thing is, yeah, I think I would like to just continue to see, out just like not necessarily in Solana, but in the crypto community in general, like continued research into like aggregate signatures that are like quantum safe and performant enough that you could replace something like Alpenglow, because right now, like aggregatable signatures are kind of this like hand wavy, like pipe dream thing. Like, oh yeah, yeah, we can probably do that. But there's a lot of quantum constructions that are sort of not mature enough yet to replace our existing elliptic curve cryptography. But to be honest, like progress has been good and fast. AI is accelerating that rapidly as well. So I like our chances, to be honest. Like we have a good shot
Nice.
at being ready, like I would say easily 5 to 10 years before we need to be.
Amazing. Amazing. All right. So we've gone through the long form questions. Um, we're now down to the rapid closeout. So I'd like to ask if you could answer briefly in, one sentence or one word for the following four questions. What's one mistake that new Solana developers still make?
Reading the Solana program library repo and thinking that that's how you should write programs. Just don't do that. Just like go to Blueshift and learn to code from there. You will end up learning much faster and writing much better programs.
So what's one cryptographic tool or an idea that more founders should understand?
Oh, sharks.
That's a good, one word answer. Maybe you can expand on what that is, just for people who are not familiar.
Yeah, so Starks are like a post-quantum ZK proof that doesn't require a trusted setup, which is just like super crazy, crazy good. The downside is they're really large. Um, so if we can get something that approximates a snark but is like has those properties, then we're going to be, really, really great long term for like protecting things like private transfers and stuff like that. So Starks are kind of like I think, a category defining sort of. It's like Starks to me are like like what RSA was for like for cryptography before we realized like oh like elliptic curves could give you much smaller keys and yada yada yada. So I feel like Starks are kind of like RSA, and I think we're going to end up with the sexy small elliptic curve type thing.
Starks are now what RSA was 40 years ago, right?
Yeah.
Or even more. The next question is from our previous guests, who asked, what risks are people not talking about sufficiently in Web3 at the moment?
Hmm. What risks are people not talking about sufficiently in Web3 at the moment? I don't think that people understand the risks involved with things like restaking and rehypothecation. Um, I think like those are very scary things that could have very bad results, and one hack and everything it falls like a house of cards. So I think people should, like consumers, should learn the risks of those things.
I was expecting you to say the quantum risk.
I don't
So
think
that's a
that's the
good,
sort of thing that's likely to bankrupt you tomorrow. So
yeah,
this
yeah.
could be, right?
Hmm.
Yeah.
No, that's a great point. And what question would you like to leave for our next guest?
What do you think is the most elegant design you've seen on Solana?
Oh, that's a good one. That's a good one. Well, thanks so much. There you have it, folks. A great episode with Dean Little. Dean, please let our viewers know where they can find you and where they can read more about you or Blueshift.
Certainly. You can find me on Twitter and GitHub at Dean M. Little, and you can find us on Twitter at Blueshift or at our website, blueshift.gg.
Amazing. Thanks so much for being on today, Dean. Wishing you a great rest of the week.
My pleasure. Thank you.